Good afternoon. Make sure everybody has a pen that is not black. Typically I say red, but just to make it easier, any pen that is not black, go ahead and get that out so you can make notes as we go. If your work does not match what we go over, go ahead and add it in with your pen so that you can see what you did versus what we talk about here in class. So first of all, show the derivative. So I did the quotient rule. If you change this into a product rule, then your work probably looks different. But I went ahead and did the quotient rule. So my quotient rule was denominator times derivative of numerator minus derivative of denominator times numerator all over denominator squared. So we can simplify that to 1 minus natural log of x over x squared. And you knew that was going to be that answer, so hopefully you could set up your product or quotient rule appropriately. Okay, write an equation for the tangent line. We need two things when we write the equation of the tangent line. First thing is we need the derivative at that coordinate. So we can just take this guy over here and plug in e squared okay. If we remember our rules of logarithms, those cancel out and we have 1 minus 2, which is -1, and e to the fourth is our denominator. The second thing we need is a y coordinate. So f of e squared, that the square, is going to be natural log of e squared over e squared. Those cancel out. They undo each other. So we have 2 over e squared for our y coordinate. So our line is going to be y minus 2 over e squared equals -1 over e to the fourth, that's our slope, times x minus e squared. There's our line. Okay, the x coordinate at which the point, of which the point f prime of x equals 0. Okay, so we need our derivative to be 0. Now, it's a fraction, so we really only care about the numerator, which means 1 equals the natural log of x, which means x equals e. That's all we need to do there. And now we need the x coordinate where our second derivative is 0. So first of all, we need the second derivative. So second derivative, I'm going to go ahead and use the quotient rule again. So we have -1 over x times x squared minus 1 minus the natural log of x times 2x all over x squared squared. Okay, so that's going to be able to simplify to -x minus 2x plus 2x natural log of x all over x to the fourth, which then can be simplified to -3x plus 2x natural log of x all over x to the fourth. And then if you notice, there is a GCF of an x in the numerator, so we can factor that out and cancel with one of the x's in the denominator. So here is our second derivative. We want to know where that's 0. Since it's a fraction, we really only care about where that numerator is 0. So x is e to the 3/2. Okay, so if we were to give some points here, I would say we have 1 point for setting up either the product or the quotient rule. I would say a point for your derivative, a point for your line. I would say a point for setting this equal to 0, a point for your answer. A point for setting up the quotient rule for the derivative, a point for the simplifying. Well, how about we do this? Not for simplifying. How about a point for setting it equal to 0, point for solving e to the 3 halves. 1, 2, 3, 4, 8. And let's come up here and give a point here for the y value. There's 9 points. Okay. All right. Now, let's go to number 2. Number 2, show the derivative. Okay, we know what the derivative needs to be, so make sure that your algebra makes sense and we have enough steps to follow it. So we need to do a product rule, derivative of x times y squared plus x times the derivative of y squared with that dy dx minus a product rule. So derivative of x cubed times y plus x cubed times the derivative of y equals derivative of 6 is 0. Okay, so let's organize. We have 2x, y, there should not be a square right there. Sorry about that. Talking and writing at the same time. So 2xy dy dx minus x cubed dy dx. So my dy dx is on one side. My non-dy dx is on the other side. Okay. We need to factor out dy dx's so that we can divide them over to get what they asked us to get, right? It's always nice when you know what answer you're trying to work towards. I like these problems for that reason. Okay, so now I'm guessing on B and C, and this is why I made this video, since I'm not there to answer your questions today. I'm guessing B and C, you had an idea of where to start, but some of you might have gotten a little iffy about how to get all the way there. So first of all, if we want a tangent line that is horizontal, we need to set dy dx equal to 0. And since we have a fraction, we really only care about the numerator. Okay, well, oh, whoops, there's a y right there, isn't there? Yep, okay. So look how there is a y in common that we can factor out. So either y equals 0 or 3x squared minus y equals 0. Now, look up here. If we were to plug in y equals 0, that's not going to work. So that one's not going to help us. Okay, so we need to work with this. Basically, y equals 3x squared. So let's come up to that original and substitute it in. Okay, so we have x, y squared, minus x cubed, y equals 6. So we get 9x to the 5th minus 3x to the 5th equals 6. So 6x to the 5th equals 6, which means x to the 5th equals 1, and x is 1. Okay. I did want the point. When x is 1, we know that y would be 3. So, probably shouldn't write in that highlighter, huh? 1, 3 is the coordinate answer I am looking for. Okay. Now in part C, it's going to go very similarly, but we want a vertical tangent line, which means we want dy dx to be undefined. Therefore, we're going to set the denominator of our derivative equal to 0. Here we have an x we can factor out. So either x is 0 or 2y minus x squared is 0. Here we have that same problem where if we plug x as 0, it's not going to work into that original equation. So we're stuck with y equals x squared over 2 if we solve that out. Okay, so now we're going to substitute that back in. We have x times y squared minus x cubed times y equals 6. Okay. So then if we make common denominators and we add these two together, we get negative x to the 5th over 4 equals 6, or negative x to the 5th equals 24, which means x is going to be negative the 5th root of 24. Okay, ladies and gentlemen, plugging that back in is ugly. It really is ugly. If you did, your coordinate is negative the 5th root of 24, comma, negative the 5th root of 576 all over 2. Okay? Probably not going to worry about that in terms of points, okay? Because I know that that was ugly. So here we go. Points. 1 point for implicit differentiation, 1 point for having correct algebra to get to the right derivative. Okay. Part B, 1 point for setting dy dx equal to 0. 1 point for subbing in. 1 point for subbing in y equals 3x squared. 1 point for the answer of 1, and 1 point for the answer of 1, 3. Part C, 1 point for setting dy dx equal to undefined, or basically this right here. 1 point for subbing in x squared over 2, and 1 point for getting this guy right here. So there's your 9. Okay, same thing as yesterday, put your score out of 18 and hand those in, and I'll take a look at those. Okay. Next thing I want you to do, there's a computer cart, okay? So don't go yet, but I'm going to explain what's going to happen. I'll send you up in groups, small groups, to get a computer. You're going to get into Desmos and you're going to do an activity. While you work on this activity, it's fine to turn and talk to your neighbors. Okay. When you're done with the activity, you can pick up your multiple choice worksheet for your homework. When you put your computer away, it does need to be wiped down. So what I'll have you do is I'll have you wait until the end of class when the sub comes around to spray your desks. Take the towel to wipe your desk, and then wipe down the computer and put it back. Okay? So, if you sit in the row that is closest to the door, go grab a computer. Okay, if you sit the row second closest to the door, go get your computer. if you sit in the row closest to the outside wall, go get your computer. And last but not least, if you don't have a computer, go ahead and get one. So what you're going to do, you're going to go into not Desmos.com. You're going to go to student.desmos.com. I can't get rid of my keyboard there, sorry. And you're going to type in this code. Put your name so I know who is who. But you are welcome to turn and talk as you go through this. So in this activity, you're going to be matching up derivative graphs with their function graphs. You're going to be matching up second derivative graphs with their function graphs, doing a little bit of explaining, but just kind of remembering how we tell the difference between a function and its derivative graph and its second derivative graph. And then, like I said, when you're done, go ahead and show the sub that you're done, get your homework, and then at the very end, make sure you wipe down your computers with the towel that you wipe down your desk and put them away.